Alright, so today we'll be talking about theorems about roots of polynomials equations, okay? And we are going to kind of go in reverse order. We're first going to talk about rational root theorem. Now last time you probably were asking yourself, hey, Mr. Devaney, I don't understand how you started out with a factor is x plus 5. How do you know that? How do you start with that? You can actually start that with pretty much any problem as long as you know the first and the last terms of a polynomial function, because you can actually discern through the rational root theorem what the factors are going to be. Okay, so let me give you one right here. Let's go 2x to the third minus x squared plus 2x plus 5 equals 0. Okay, so what the rational root theorem is saying is that if I take the factors of the last and divide it by the first, so let's call this p of x, and this one as q of x, okay? And the rational root theorem says if I do p of x and I divide it by q of x, the factors of, mind you, there is bound to be one of those factors or one of those fractions that actually is going to be one of my roots. Okay, so what I'm going to do is I'm going to set it up. Okay, we're going to have the factors of 5, which is plus or minus 5, comma, plus or minus 1. Those are the factors of 5. Makes sense. Okay, and I'm going to divide that by the factors of 2, which are factors of 2, which is plus or minus 2, comma, plus or minus the factors of 1. Okay. All right, so what I'm going to do is do a combination thereof. Okay, so I'm going to divide 5 by the 1. So I get plus or minus 5. Okay, and then I'm going to divide it by the 2's. So I'm going to get plus or minus 5 halves. Okay, so those are my first two factors. Then I'm going to divide by the 1's. Okay, so the next one I'm going to have plus or minus 1. Okay, because I'm going to go 1 divided by 1, and then I'm going to have comma. I'm going to do the 1 divided by 2, so that's plus or minus 1/2. So these are my possible factors. Now you're probably asking yourself, which one is it? Okay, and what you're going to do is you're going to do synthetic division over a couple of times to actually find out which one gets you 0. Okay, all right, so if we do synthetic division, okay, we set it up. We're definitely going to have the 2, the -1, the 2, and the 5 in here. Okay? Alright, and so we test it out. Let's say we test out the 5. Okay, so I test out 5. So I have the 2 down here. So 2 times 5 is 10. So this becomes 10. This becomes 9. 5 times 9 is 45. Okay, that's getting big real fast. I somehow don't think that 5 times 47 is going to be -5. Alright, so that doesn't work. So I know that that is not one of the answers. So I can go ahead and erase these and just get rid of that. Okay, now I could try another number and just work my way down the line. Now it looks like -5 might be the same type of result, so if I try it and I don't like where it's going, I can stop and just work on from there. So this turns into -10. Okay, and this becomes -11. I'm already having a bad feeling about this. Times -5, which is going to be 55. Yep, that's not going to get my answer. So I'm just going to go ahead and backtrack and go back to say that the factors of plus or minus 5 definitely do not work. And you can go down the line and just work this way. Now, if we try another one, let's try simple ones, -1. Negative 1 times 2 is negative 2, so this becomes negative 2, and this becomes negative 3. Now don't abandon this just yet. It's small, like something could happen. This turns into a 3. This turns into a 5. Oh, look at that. Negative, or 5 times negative 1 is going to be negative 5, which is something we want, and that turns into 0. So whenever we get a 0, we know that that's a factor. So we know where to start. And this will actually help us when working with, okay, a blank sheet, like just a polynomial function that you know has roots. This helps give you these ideas. Now, are all these going to work? No, they're definitely not going to work. So you just have to take your time and just work with them. Now, another way is graph it. Okay, and this is the new fashioned way of doing it. So we have 2x cubed minus x squared plus 2x plus 5. Okay. All right, as you can see, 1 is the only one that's really crosses and stuff, and so the rest are just going to be kind of a little bit funky right off the bat. Okay. All right, if we zoom out, we can't see anymore, but as you can see, negative 1 was the right one to pick. Okay. All right, now if we look back at this one, we will probably have to do quadratic formula. So what that means is, since it only crossed once, we're probably going to have to do quadratic formula and see that we're going to have some imaginary answers in there. Okay. Now you may be asking yourself about these theorems right here. Like, how many times do I check this? And you know, you're probably asking yourself, well, if we check this once, and if you notice, that's just one of the, what is this, 8 different possibilities we could do. Do we need to test the other 7? And that's a great question, because this will actually help you get the real answers. And it's called the degree, I like to call it the degree answer theorem. Okay, so the degree answer. Whatever the degree is, that and every 2 below is your possible real answers. Okay? Ugh, look at that. That's ugly spelling. Okay? So, for example, if my degree is 4, that means that I have 4 or 2 or 0 real answers. So in other words, I would know when to stop checking my possible rational roots. Okay? If my degree was 5, okay, I would take 5, and then I would minus 2, or 3, and then minus 2 again, or 1 real answer. Okay, so that's how many possible answers I would have just by looking at that. So I could actually tell you, all right, since we have 1, and I know this degree is 3, okay, so here, let me go back to this problem as an example. Degree is 3, so that means there are 3 or 1 real answer. So if I get done and I checked 1, I would know, okay, either that's all for my real answers, or I would have 2 more. I wouldn't have to check. If you notice, we only did this 3 times already, and we checked once. Okay, I wouldn't need to do plus 1, plus 5 halves, negative 5 halves, plus 1 half, negative 1 half. If I found out that like these 2 also counted, I wouldn't even need to test these, because I know that I only have 3 or 1 real answer, and it turns out I only have 1 real answer. The other one's imaginary. Okay, so this will actually kind of help you figure out what's going on here. Okay, all right, now the conjugate root theorem is if one of your imaginary answers is a plus bi, then your other complementary imaginary answer is a minus bi. Okay, so in other words, if I knew one of my roots was 3 minus 2i, then the conjugate of that is also an answer. 3 plus 2i is also a root. Okay, now how does that help us? Now if you notice down here, the degree was 4. The degree will actually tell you how many answers you have, but you can use this little trick to tell you how many real answers you have. So now if I have 4 real answers, let's move this off to the side a little bit just to see it. Okay, that means I have 0 imaginary. Now if I have 2 real answers, I have 2 imaginary. And if I have 0 real answers, that means I have 4 imaginary answers. And that's the cool thing about this, is you can use it as a complement. Okay, so that also works for degrees of 5. So this means I have, if my degree is 5, then I have 5 and 0 imaginary roots. Or if I have 3, I could have 2 imaginary roots. Or if I have 1, I could have 4 imaginary roots. And remember, roots, answers, they're all interchangeable. They all mean the same thing during this time. Okay? All right, so that's the conjugate, and that actually helps explain why the conjugate always comes in pairs. Okay? Now, here's another one. If I knew 2i was a root, I would also know that negative 2i is also a root. Okay, the conjugates just go together hand in hand. All right. Now, Descartes' rule of sign change. Now, I'm going to take this one that we originally did. Okay, and I'm going to beat the crap out of it because it's just, it's just there. Okay, René Descartes' rule of sign change will tell us how many positive real roots we have. Okay? René Descartes' rule of sign change. So what I'm going to do is I'm going to look at the sign of each term. Okay, if you notice, I go, and it's sign change. So if I change from a plus to a minus, that's a 1. So this is 1. I change from negative to positive, that's 2. I don't change here, so that's nothing. So this means I have 2 possible real, or 2 positive real roots, at least. Well, no, not at least, at most. Okay? And it turns out I did have 0. So that was actually, kind of accurate. So I had 0, if you don't remember from earlier. Okay. Now, if I plug in a negative x, okay, into each one of those x's, all right, so I would get negative 2x cubed minus x squared minus 2x plus 5. Okay, if I plug in a negative x, this will tell me how many negative real answers I have. Okay, so if I start here, I go from negative to negative, that's 0. Negative to negative, 0. Negative to positive, that's 1. So I have 1 negative real root. Okay? And it turns out that that actually does match up with everything that we have talked about, because I actually did have 1 negative. Okay, and so that's how you check them out, and that's how you've worked with them in the past. In the meantime, you guys, feel free to graph, but if you need exact answers, you actually have to go about the exact way of doing it, okay? Thank you. Have a great day. Bye.